Here's geometry, unit 7, day 3. We're working on proportions for geometric problems. Some of our I can statements is that I can simplify ratios. You can write proportions. Remember, proportions are a fraction equals a fraction. And you can solve the proportion. We'll solve them by cross multiplication. Ratios and proportions, if an A and B are two numbers or quantities and B is not 0, then the ratio of A to B can be written as A to B. That's one way we often write it. We often write it as a fraction, A to B. An equation that states that two ratios are equal. An equation, that was the part I missed. An equation that says that two ratios, in an equation that has two fractions that are equal, is going to be a proportion. So first we'll talk about simplifying. Here's one way. So you're looking at the numbers that would go into both of these. If you only realize that they're both even numbers, then you can cut them down and call that 38 to 4, but you might notice those are both even numbers. So you can divide that by 2 again. So 19 to 2. Here we have our fraction, but here you've got to be careful about the units. The units here, we have feet and we have inches. It doesn't matter which units you use, but they both have to be the same. It might be easier to turn 24 inches
into 2 feet.
Into 2 feet. So what we do is we take 24 inches and we divide those into 12-inch groups, and that gives us 2. So we have 4 feet over 2 feet, which simplifies to 2 over 1. But you have to have the units the same. You cannot simplify if the units are not the same. Here we have the units the same. Notice that this has the word 2 in between. Okay, 4 to 18. A to B, A to B. A third way to do it is to actually have the word 2 in between them. But you would just think about dividing each one by a number that goes into both of them. So you would have 2 to 9. Here we have our yards and feet. There are 3 feet in a yard. So again, you can go either direction. You can either change the yards into feet, or you can change the feet into yards, your choice. Here we would have 33 yards. And we would have 3 yards. 3 yards are 9 feet. If you have your 9 feet and you divide those into groups of 3 feet, that's going to give you 3 yards. So here we would divide by 3 to simplify it, and we get 11 to 1. So that was about simplifying the ratio, just normal. What's kind of weird is when it's not in a fraction form, or what's even weirder is if you've got to watch the units. You've got to get the topic into reasonable units. Okay, here is an important one. You might see this one on the SAT. The measures of the angles of triangle BCD are in the extended ratio of 2, 3, 4. So we're going to have this triangle. I just draw a generic triangle. And we have BCD. And what they're saying is they're in a ratio of 2 to 3 to 4. That means the angles might be 2, 3, and 4. Or they might be 10, 15, and 20. They might be 20, 30, and 40. They are some reduced numbers down to 2, 3, 4. So we just don't know what the numbers are going to be. So we look here, this is a triangle. We know the sum of the angles of the triangle are going to add up to 180 degrees. So if it adds up to 180 degrees, then we know that 2 times something plus 3 times something plus 4 times something, this is in a ratio of 2 to 3 to 4, 2 to 3 to 4 is going to equal their relationship. You got to figure out what is their relationship. In this case, they all add up to 180 degrees. So this is 7, 8, 9. So you have 9 x's equaling 180. And divide by 9. And x is 20. So what are the measures of the angles? Well, it's 2 times 20. It's 3 times 20. And it's 4 times 20. Those would be your 3 angles for a triangle that can be reduced into 2, 3, 4 that all add up to 180 degrees. A lot going on. So that was for a triangle. Now we're going to look here and we're going to notice that they're referring to the perimeter of a rectangle. The perimeter of a rectangle is 21 feet. So all the way around is 21 feet. That's what we know for sure. The ratio of the length to width is 5 to 2. So we'll call this length and we'll call this width. And it's not that they are 5 and 2, but there's some multiple from 5 and 2. They're either 10 and 4, 50 and 20, 500 and 200. There's some multiple. So a good way to write it is 5x and 2x. Now, if we were going to talk about perimeter, then we know that this side is 2x and this side is 5x because opposite sides are congruent. Perimeter, you can do that a couple different ways. Perimeter equals 2 times the length plus the width. That's your typical formula for perimeter of a parallelogram. This is a special type of parallelogram called a rectangle. We know we have 21. Your length is 5x and your width is 2x. That's a total of 7x. By multiplying the 2, we got to 14x. and 7 goes into that 3 times, and 7 goes into that 2 times. So your x is going to be 1.5, or known as 3 halves. When we're solving a proportion, things that you learned back in middle school in Algebra 1, we're going to use cross product property. We're going to multiply across from each other. And the reason that that happens is because to solve for b, you would multiply b to one side and b to the other side. They cross out here, so it's like we put the b on the other side. We just cross it. Okay, where the denominators cannot be 0. We're going to have AD, A times D, being the same thing as C times B. So if we're going to solve these, we would solve cross multiplying 48. Well, here I jumped the gun there a little bit. Why don't I show my work to say 3 times 16 equals 4 times x. That is 48 equals 4x, and divide by the 4 to get 4 goes into 4 once, 4 goes into 8 twice. So if this is at 3/4, what would be the numerator if 16 was your denominator? To have that same ratio, this would have to be a 12. Some people like to look at it as if you multiply the 4 by a 4 to get to 12, then you multiply the 3 by a 4. I'm sorry, 4 by 4 to get to 16. You multiply 3 by 4 and you make 12. That's another way to solve these, but cross multiplying is what we're focusing on. So we cross multiply. 5 and 8 make 40. 2 and y, divide by 2, we get 20 equals y. Now we get into a little bit more complicated ones. Look at what you're doing. When you cross multiplying, you're saying 9 times x minus 3 and 3 times 2x. So that's 9x minus 27 and 6x. So typically I like to keep my x positive, but this will save us one step. When we divide by the negative, we get x equals 9. Next, we'll flip the page. We'll look at some other properties of proportions. This is more now coming to a geometry point of view. If two ratios are equal, then their reciprocals, if you flip the fractions over, their reciprocals are also equal. If you interchange the mean of a proportion, okay, we saw when we were looking at the book, the mean are typically known as the denominator of the first fraction and the numerator of the second. You can interchange those because ultimately you're multiplying the same number. It doesn't matter what order you go into. In a proportion, if you add the value of each ratio's denominator to its numerator, That's a little complicated sounding. We'll give that one a try as we move on. So let's use these proportions now to help us work with these problems. In the diagram, we know that AC is 12, DF is 18, BC is 9, and EF is X. We're supposed to write different proportions. We can do the reciprocal. We can do 18 over 12. We can do X over 9. We can flip both the fractions and you have the same, you'll get the same value for X because you're still doing cross multiplying. So the 8 and the 19 are still multiplying each other. The X and the 12 are still multiplying each other. Another one that it talked about is to change the mean, change these two values. If you switch those, and so interchange the mean. So we're going to switch the 18 and the 9. So we're going to have 12 over 9 equals 18 over X. If you cross multiply, it's still going to be 12 times X. And it's still going to be 18 and 9. So you still get the same value. It completely works. And then the last one is this denominator. So looking here at the original one, if you take the 12 plus the 18 over 18, and you take the 9 plus the X over X, and if you were to cross multiply, we would still get the same value for X. It wouldn't matter. Here, it doesn't make a lot of sense to do that. But there are some problems that have that property, and this is why it works. So solve for X. You can use any of these. If we had all the time in the world, we would have a group of you solve it this way, a group of you solve it that way, solve each type of proportion. But right now, we just have time to work through one set. Now you have a choice. You can either reduce your fraction first. 6 goes into 12, 6 goes into 18, so you can call it 2/3 if you want. Or you can cross multiply, so you get 12x because it's 12 times x, and you get, let's see, if this was 18 times 10, that'd be 180, but it's only 9 times 18, so that's 152. Then we divide by 12. I don't know what that is, but I do know that 12 goes into 15 one time with 3 left over. 12 is going to go into 32. It doesn't go into 32, but it goes into 24 twice with 8 left over, 8/12 left over, which is 12, and 4 goes into that 2 times, 2/3. 12 and 2/3. That would be the same thing we'd get for each of those different examples. Here, we know what the ratio is. They give us the ratio. In the future, you're going to have to write your own ratio. But right now, they're giving you the ratio. They're saying that part of this side over the little part equals part of the other side over the little part. So they're not just random. They actually are related in the shape. So if JL is the unknown amount, LH is 2, JK is 16, KG is 5, we get 32 there. All right, so we know that 5 goes into 36 times. So this is 6 and 2 left over, 2/5 left over. You could also call that 6.4. So now if this is 6.4, I don't really remember that being the answer, but going over my work, all right. JH is going to be 2 more than that. JH is going to be 8.4, and then JL, and that's what we calculated for. We already figured out JL. All right, so that's one way to do it. All right, last problem. KL is, oh, that's not a 16, that's a 15. I have old man eyes. All right, my bad. This is a 15. That's a 15 right there. So that's going to make that 30. That's why I don't remember that as being an answer. That's 30. So that goes in there 6 times. That's so much nicer. Okay, so it's 6 plus 2, which is 8. Okay, sorry about that. That is a 15. Now we come over here, KL is 12. GH, that is our unknown. JK is 15. And GJ is 15 plus 5, which is a total of 20. Now, if you would like to reduce your fraction, because you don't want to do 12 times 20. So we have 12 over GH equals 3 over 4. Cross multiply, and we get 48 equals 3 GH. Divide by 3, and GH, here's our 16. All right, good work, everybody. Proportions. Proportions can be your friend.